Let's get started looking at how to utilize dependency injection in our Globomatics Xamarin Forms solution. Dependency injection can be defined as a technique whereby one object supplies the dependencies of another object. The intent behind dependency injection is to achieve separation of concerns, of construction and use of objects. This can increase readability and code reuse. Let's work our way through a C# example. Let's say the application needs functionality related to adding customers. We can start by creating an interface for adding a customer. Let's call it the iCustomerService, as you can see on the left. It's an interface because we are not concerned with implementation details as of right now. Then we can implement that interface in a class, as you can see on the right, called CustomerService. Then when we want to use that functionality, we can pass the interface in as a dependency to a class that wants to consume the functionality as seen here. We pass in the CustomerService interface in the constructor. That way we can use any implementation of the interface. Dependency injection containers reduce the coupling between objects by providing a facility to instantiate class instances and manage their lifetime based on the configuration of the container. During the object's creation, the container injects any dependencies that the object requires into it. If those dependencies have not yet been created, the container creates and resolves their dependencies first. There are several advantages of using a dependency injection container. A container removes the need for a class to locate its dependencies and manage their lifetimes. A container allows mapping of implemented dependencies without affecting the class. A container facilitates testability by allowing dependencies to be mocked. A container increases maintainability by allowing new classes to be easily added to the app. This encapsulation technique allows for decoupling the separate layers. Now we can have the DAO layer implement the DAO interfaces. Those interfaces are used in the customer service, but the customer service is not dependent on the DAO implementations. And then the view model layer can be the same with the dependencies on the services and the DAO without needing to be coupled with the implementations. Before dependencies can be injected into an object, the type of the dependencies must first be registered with the container. Registering a type typically involves passing the container an interface and a concrete type that implements the interface. There are two ways of registering types and objects in the container through code. Register a type or mapping with the container. When required, the container will build an instance of the specified type. Register an existing object in the container as a singleton. When required, the container will return a reference to the existing object. After a type is registered, it can be resolved or injected as a dependency. When a type is being resolved and the container needs to create a new instance, it injects any dependencies into the instance. Generally, when a type is resolved, one of three things happens. If the type hasn't been registered, the container throws an exception. If the type has been registered as a singleton, the container returns the singleton instance. If this is the first time the type is called for, the container creates it, if required, and maintains a reference to it. If the type hasn't been registered as a singleton, the container returns a new instance and doesn't maintain a reference to it. Registering and resolving types with a container has a performance cost because of the container's use of reflection for creating each type, especially if dependencies are being reconstructed for each page navigation in the app. If there are many or deep dependencies, the cost of creation can increase significantly. Most containers allow you to specify the lifecycle of the objects resolved, so understand when objects are needed in a singleton context or a new instance per. The dependency service class is a service locator that enables Xamarin Forms applications to invoke native platform functionality from shared code. The process for using the dependency service to invoke native platform functionality is to create an interface for the native platform functionality in shared code, implement the interface in the required platform projects, register the platform implementations with the dependency service. This enables Xamarin Forms to locate the platform implementations at runtime, resolve the platform implementations from shared code, and invoke them. In the next section, we will demo using a dependency container and the dependency service.